All right, welcome everybody. We are going to be working on module 3 tonight, so we're going to try to get through these lecture materials. Our general agenda for the evening is on slide number 2. So these are the 3 main topics we're hoping to cover. The first 2, by the way, are kind of an extension of last week's module. So we're still kind of thinking about selection as one of the big tools in programming or decision making. Conditional operators and the switch statement are kind of basically alternate forms of the if statement that we use to make decisions in programs or to create branches in the code. Both of these 2 that we're going to look at are very powerful and very, very useful in programming. I might even argue that some of these are, maybe preferred over if statements in some situations. The other topic is talking about functions, and we're going to qualify this and say local functions, meaning that we would be building the functions as opposed to using ones that are pre-built. And this is a really important thing because that kind of puts us into this mode where we're creating reusable blocks of code that we can call in by name. So we're creating it, then we will be able to use it over and over again. And programmers who get really smart, by the way, are really big on when they create local functions to create libraries of them, and store them, and I've done that historically in all of my coding work, both when I'm creating like web pages or applications or apps or whatnot. Because if you create something useful and you can reuse it, that's fantastic, right? It saves a lot of work. Hey, I've already done that before. Why not just reuse the code I already have rather than create something from scratch? Let's go into the first topic here, and we're going to learn about what we call the ternary operator. And here they are on the screen. That question mark and that colon are the operators. They're the replacement for if and else. And that's really kind of bizarre. Yeah, those 2 characters. This is a really modern approach to writing an if statement. This has actually been around for a while, frankly. But what's happened over, I'm going to say, of course, the last 15 to 20 years is all the major languages now support this. So if you learn how to code like any C style language, right, or Python or JavaScript, and then the list goes on, like you could learn how to code in like Ruby, for example, like oddball languages, all of them support the ternary operator because it is so common in programming. It basically really is a mini if else statements. And notice the thing that says on the bottom, and I agree with that statement very strongly. It's most commonly used to assign either an either or value to something kind of on the fly. It creates really efficient code and makes, at least from my perspective, like taking like everything we see on the screen right now and being able to squeeze it into one line, right? But still functionally have it do exactly the same task. And that's powerful, right? So how many lines of code do we have here? Well, it's 6 lines of code. And even though we're being efficient and not putting in the curly brackets and the if and the else, right? Remember my whole mantra on that. You're better off putting it in than not. But take a look. We have a score variable, right? 78. We have a message variable that's initialized to nothing to start with. Then we check and see, hey, if the score is less than 60, the message will be you fail. Else, the message is you pass. Okay, that's not really complicated. And you know what? I can write code like this and it'll work all day long and it'll be just fine. It'll compile great. User would never know the difference. If you really start to analyze, how this kind of breaks down, here's really a more effective sort of way to write this. So check out the syntax here. I take the Boolean logic, so like the test of the if statement, and I still put it at the beginning of the statement. So I'm considering this spot here the beginning of the statement, right? Remember, equal sign means whatever's on the right gets stored in whatever's on the left, right? So ultimately, we're assigning a variable, right? Now, could I also put at the beginning of this var message? Yeah, totally. You can do that right on the fly like that. All right. But here, we're putting in the logic, we're doing the test. So this is the if. So if score is less than 60, and then I guess you could look at the question mark as then do this. So if it's true, we do what's after the question mark. If it's not true, the else comes after the colon. So then we do you pass. And notice the simplicity here. I don't have to say message equals you fail or you pass. The assumption is whatever this is going on in this one or other of these statements is getting stored in this variable. That's the whole thing of it. I mean, and it's not really very complicated when you start to look at it. Now, you can also kind of extend that out. You know, if you look at, you know, the question mark and the colon, you'll see this code in other languages, right? As well. Very commonly used. I remember the very first time I encountered it. I think it was like when I was doing Java, and it was quite a while ago. And I was looking at it and going, what the heck is this? And I had to like research it. You know, I had no clue because it was brand new at the time. And yeah, and I've like, you know, subsequently memorized this term ternary operator. So in this example, right, here we're looking to see if x is less than 0. If it is, if that's true, then the value we're returning is 10. Otherwise, we're returning 20. These are hard coded, right? You could have variables here. You could have function calls here. You could do anything you want here, right? But usually when we do a ternary operator, the if statement ask is very simple, and the return values coming from the then and the else are also typically very simple. So it works really well in a scenario like this. Really what this is missing, if you think about it, we're not declaring what x's value is, right? But we're assuming somewhere else in the program, we set the value for x, and now we're testing it to see if it's negative. Basically, that's what this does. And if it's negative, y becomes 10. If it's not negative, y becomes 20. Any questions on how that works? I'm not demoing this, but I think it's pretty clear cut. I think that when we do some of our coding work, we'll get plenty of a chance to demo it. So that was our first topic. That went pretty quick, right? That was like 10 minutes. Let's move on to our next major topic, which will take us a little bit longer. And we're going to be looking at what we call switch statements. Now you will notice here that we have a slide that is a flow chart. And normally when we reach a decision point in a flow chart represented by a diamond, it's usually true false, right? And so we ask a logical question and we say, hey, if this statement is true or false, you either go this way or you go that way. There might be just statements on the if side, right? If true, there might be statements on the false side or not. It depends on how you structure it. And then you can branch down to additional ifs if needed to get to the logic that you need. All right, so think about this. What if we had a different kind of structure where maybe we're looking at a different sort of case, you know, and I'm using the term on purpose. You know, for example, you know, like, hey, I might write code that says, hey, what month were you born? Okay, well, how many possibilities are there? Well, there's 12, right? There's not 13, there's not 11, right? So there's 12 choices. And you see, in this case, they're looking at, you know, the value of a month. They're doing this as an integer, which is kind of odd, but basically 1 through 12 would work, correct? And then for each integer value that we would put in, now we're only showing a few of the months, right? Maybe there's a reason for that, but it could potentially be all 12, or maybe we're just looking at a certain range of them. But we would take that number, we would match it up with the situation, and depending on which situation it matches with, that's the code stream that we follow. Now, what happens, you know, under that branch? Well, that depends on what the program is doing. It might be a complicated series of steps, or it might just be setting a single value. here's kind of an interesting situation about this, right? And I'm trying to give you like practical scenarios. Like when you're, let's say, operating an app or you're visiting a website. And I was doing this a little bit today because I was taking care of some medical bills. And, they ask you all these questions and you're filling out forms and typing in information. And then invariably you get to like a thing like put in your, like your billing address or something, right? So name, address, city, state. Well, for state, I'm not typing it in. They have the little box, right? And you hit a little arrow and this list pops out and there's 50 states already loaded inside there, right? So what they're, basically doing is they're saying, well, you have to live in one of these 50 states. So pick one. Most often for us, it's going to be Wisconsin, but you never know, right? So like, I mean, we don't live that close to the Illinois border. We would have Illinois people here, but who knows, right? But I think it's pretty fascinating because in a situation like that, really what you're doing is you're choosing from a finite number of possibilities. All right. So maybe you have to be a US citizen to fill out that form. Hey, but let's throw a monkey wrench in. What if you're from Puerto Rico? All right. Well, you're still a US citizen, correct? Yes. But now your state's not on the list, right? So then we set up a branch to handle those oddball situations. Maybe you're not from Puerto Rico, maybe you're from Guam. That's another US territory, right? So you're a US citizen if you're born there, but you're not a state. You don't have statehood. So we also set up defaults. So like if one of the scenarios doesn't catch, then we have something to catch the scenario that doesn't. That's kind of the grand layout of a switch statement. So it's branching to multiple possibilities rather than an if or an else. That's kind of the grand goal of this. When we put together this in code, we basically start by doing something like this. We use the switch keyword, and then in parentheses following that keyword is the thing we are checking. And notice the difference between this and an if statement. This is not a Boolean test, right? It's not like if, month equals July. That's not at all what's happening here. I'm just feeding a value in. So imagine the scenario, I'm running a form like I was talking about, and I click, the WI for Wisconsin in the form. I would feed Wisconsin into that spot. Or if the dropdown was what month were you born, more appropriate for this example, and I choose July, July is fed in there. And then based on the situation of whatever month I fed in there, and coincidentally, July is 7 months. So if I say July and it converts to an integer, that would be 7. So that assuming the value that's getting passed in, and then we put in a colon, and then what happens after the colon is what happens relative to this branch. So we basically are looking for whatever value this is to be declared here. In this case, you're showing 2 values, but you can easily imagine case 1 through 12, right, for each one of the months. And then maybe it would be something as simple as like print July or output July to the screen, right line July. Just to kind of have you. So really what we're testing then, if you think about it, is whether or not what is being fed here is equivalent to that. So there is a decision being made. We're just looking for which one it matches up with. That's all. I think that's a nice little example. So like we could, kind of continue the example. All right, so I feed in July. July comes in as the number 7. It finds the number 7, and then it executes whatever code is listed inside of that case. And this is indented. There's also kind of like this pattern that happens too, where a lot of people, when they do case statements, don't indent it for whatever reason. I'm a big fan of the indent. We'll see how Visual Studio handles it, right? Like there's kind of this little automatic formatting on that. But notice, think about this. When we do an if statement, and let's say the true part of it hits, it executes the code in the true part, and then what happens? it jumps out. It doesn't do the else, right? Because it doesn't have to. The same thing happens here with a switch, but it only jumps out with a command that you put in manually called break. Otherwise, what would happen is if I did not have that little piece in there, it would continue processing. So if it found a way to reattach itself to one of the cases, perhaps the default at the bottom, we're not showing that yet, it might re-execute some code that you don't want it to. So what we do is if we just want it to perform this action, then we throw a break at the end of the statement on the next line, and that jumps us out of the current code block and back to the regular program stream. So that's a necessary piece here. I have seen situations where people omit it for specific reasons, and it's kind of weird. I'm not comfortable with it. I don't recommend that. I think it breaks your logic, no joke intended. Right. All right. So here they're focusing once again on the break command. We have to basically get that as the last statement in each code block, right? So just don't forget to do that is the general rule of thumb here. So an additional thing that we often add to switch statements, it's not necessarily required, but it can be a good practice. So for example, if we're listing all the months, so we have to, imagine it because there's not enough room on the screen, but let's say we have all the months, January through December, 1 through 12, right? But maybe when the user made their selection, they put in errant information somehow. I'm not sure how they would. I'm just trying to imagine a scenario where they would, you should be able to control that from your app design, honestly. But let's just say they put in a value that was not relative to what we're doing. If or maybe the situation is, hey, what if, we're only checking for July and August people, and everybody else will just say error. That's a possibility. But what happens here is if none of the cases stick, so none of the branches make sense to follow because it doesn't match up, then the default will execute. And in this case, they're just putting an error message on the screen, but it could be a more meaningful action. Like, for example, it could say like, hey, that information didn't work quite right. Do you want to try again? That sort of thing. But the default is not necessarily required. That's another important piece of this. But sometimes logically, it's really a good idea to have it in there just in case, maybe your program logic earlier in the program isn't complete and it's allowing for invalid input. And it might help you catch it, right? But it is useful for doing a bunch of different types of scenarios. So switch statements are sometimes also called case statements or switch case statements. You hear it all different ways, right? I think of them as switch statements, and the cases are the branches. But if you hear somebody say, hey, let's drop a case statement in there, that's what they mean. It's the keyword is still switch. Cases just refers to all the unique scenarios inside of it. When you do set up case statements like this, right? You do have to make sure that each case that you are checking is unique unto itself. So I can't have 2 listings for number 8, for example. That's not a good idea, right? Why? Well, let's just hypothetically say we did that. Well, the first one would catch every time. The second one would never be hit because it still will read sequentially through the list, right? So if you had 2 case 8, the second one would never, ever be executed. Right? So that's why it has to be unique. The other thing that you can do is you can also stack them, and that's actually what they're showing here. So you notice with case 7 and 8, they're listing them in this fashion. And I find it's always interesting because different languages will do the stacking in different ways. Today I was working with Swift, which is an Apple programming language. And if they were stacking cases, they just do it like this. They just put them on the same line. I don't know if C# supports that. I do not believe so. I think the only way you can stack them is like this, but you can list them two in a row. So if 7 or 8 hits, then this code will execute. And that's called stacking. How many can you stack? I don't know. How many can you fit in your code? As many as you want. So maybe if somebody's choosing a drop down of all the all the US states, all 50 of them, maybe all of those resolve to the same thing, like, yeah, you're fine to pay. And maybe if you hit Puerto Rico or Canada or Guam or whatever, then the default kicks in and says, sorry, you can't do this. Just kind of giving you scenarios to think about. There are a little bit of limitations for switches, right? It only checks to see if something is equivalent. So I cannot, right, do greater than. I can't do Boolean logic here. I can't test for true or false. I can only see if this matches one of the case values. There's no greater than or equal, well, no greater than or less than equals intrinsic, or equivalent really is the better way to say it. The other thing that it can't do is range checks. Okay, so, and this is fascinating too, because other languages do allow for that. So some languages allow you to, for example, say, hey, if the number is between 1 and 10, then do this. Right? And that's language specific. C# does not allow that. Right. So if you have that kind of logic, then you switch to an if statement, because you can say if greater than one number and less than a number, then it's in a range, and you can nail it down. The other thing that it can't do is, like, if you're matching strings, for example, like if you're looking at, let's say, to match a name up or something, and let's say you misspell it and one letter is capitalized that should have been and isn't, right? That won't work either. So like if you were, let's say, if a person's name is here, what you could strategically do is before the statement, convert it to uppercase or lowercase and then check it. That would be feasible. So those are all the things that you would think about in the process of doing this. Now, what I think would be a lot of fun in this situation really is to write a little bit of code to test this. So why don't we bring up Visual Studio really quick, and let's just do a really quick little ternary statement and a quick little case thing just to kind of do proof of concept, and then we'll kind of roll from there. I am going to create a brand new project here. And you can see I was coding in other platforms here. So I want to output to the console. There we go. And you know what? This is just a demo, so I'm not really too worried about what it's called. Whether or not you guys want to do the little example here, that's on you, right? You're welcome to follow along if you wish. All right, let's just do some real basics here. Let's just do an integer, call it x. Let's set it to 10. And then let's do, okay, so it's like reading my mind. I want to do 20. No, I don't want to do 20. But let's just come up with a ternary statement right now. And let's create another integer, but let's call it z. I'm trying to throw a curveball at it. And then let's do a ternary statement, really simple one. All right. Also, I'm going to do you guys the favor of zooming in just a little bit so you can see it a little better. Hopefully that helps. And here comes my statement. I'm going to just do some logic. I'm going to say if, right? The if is implied. I don't have to type it in, but I'm putting parentheses in. If x is less than 20, right? That's how that would read. And you notice how it, like, it's like auto completing this. I'm not telling it I want the 20, but I am going to hit tab and just accept exactly what it typed in, right? And so what this statement really says is if x is less than 20, then place 20 into the variable called z, right? Otherwise, put 10 in there, and then, hey, let's test it. Can I just do this? Can I just put a z in here? Would that work? Sure, why not? No harm, no foul, right? Pretty simplistic. Let's just go ahead and run this so you can see it. See that it runs correctly. There you go. Proof that it worked. Right. So that's your ternary operator, real basic example. But don't you love the simplicity of it? That's so much less code. I mean, it's kind of beautiful in a way, you know, when it comes to coding. Um, the other thing I'm going to kind of warn you about ternary statements is when you're looking at code, they're really easy to miss. Like you're looking at big blocks of code and you're like, how are they doing that? I just don't see it. And then, oh, there it is. It's a ternary operator. So if you're suspecting there's an if statement somewhere in your code that you're just not seeing, a really good character to search for is the question mark key. Or the question mark, and that way you can kind of find them in your code. Okay, so that's the ternary example. Let's do a switch now. So I already have some like variables set, right? So why not just kind of roll with those? And let's do a switch. And you know what? I am gonna, oh gosh, we can assume that the numbers that we're feeding in are months, maybe, or maybe there's state. I don't want to write too much code is kind of what I'm concerned with here. So here's what I'm going to do. I'm going to test Z. We don't know what Z is, but we're just going to use that anyhow. And now you see that I've put my curly brackets in there, and I'm going to start setting up my cases. So I'm going to say, you know, case, if the number is 0, I'm going to console write line 0. Yes, I want to do a break. And notice, I just love like the IntelliSense on this. And yes, I'm rolling with it. I'm going to let it steer the ship. Should like auto format itself. Else, if the case is, you know what, I'm not going to do 1. Let's do 10. I don't want to do a bunch of different values here. That would kind of be silly. And you notice how it also shortcutted it, also put it on the same line. Yeah, you can do that too, by the way. Right? And honestly, I could write my break statement like this. Right? I don't have to indent it. And you know what, frankly, if the stuff that is being coded is about as simple as this, you might not need to, but sometimes you will put multiple statements inside here. Let's also put in the case that we actually want, which is 20. Let's break again. This one I'm going to unindent and I'm going to move it down. You know, try to make it look sort of nice. And then let's throw in a default. And maybe this is error, you failed, etc. And by the way, when you're building, you know, code, you know, you should try to have a little bit of fun with it. Now I am getting an error here, and why? Because I have no break, right? And in fact, let me Control Z that, let it flag again. And look at the error message Visual Studio generates when you're doing this. It says, control cannot fall out of a switch from the final case label default. And they're saying you still have to have a break statement here, even if it's the default. Because what would happen after default? The program would just keep running anyhow, right? But the break hops you out. All right, so what will happen when I run this? What should be my output on the screen? Keep in mind, this is going to happen too. What did this output?
It was 20.
20. Yeah. If you remember seeing it on the screen, but you can also look at the logic and figure it out, right? All right. And then given the fact that Z is 20, what will this output?
It should be 20.
Yeah, should be 20 and 20, right? All right, let's run the code and make sure. And then we can tweak it and see if it does something different. All right, so here comes the run. Get that console out of the way, and indeed, I got 20 and 20. So it did exactly what we thought. What happens if we change this to 30? What will output?
The default, the error you failed. So
Okay.
I'm gonna guess.
Yeah. Sebastian, did you say that? Yep.
Yeah, that was me.
Yeah. Are you guys getting like a jarbled audio right now? No. Okay. Maybe I should check my clock speed on my CPU, right? Yeah, I'm good. So it's not me. It must be your internet, not mine. All right. Let's check that scenario. That would be my guess as well. Anybody have a different guess? Why will that output? Because instead of grabbing 20 to put into Z, X, which is 30, will go into Z. There's no case for 30, and so this will output. So let's run it. Check it. Right. So that is the correct answer. Could we set up a scenario where it would catch? Well, how about this for a scenario? What if we tried doing the stacking? We could do case 30 like this. And then my thinking would be that what will output is this, but maybe should correct the output at least. Right, to match, I mean, it should sort of match at least. All right, let's run it and make sure. So that's the case. So very, very quick overview of how switch case statements work. Very powerful, by the way. And you can imagine scenarios. So like, for example, I think like the drop down of a state is a great one, or the month you were born, right? Where you have really finite values. Those are often very, very useful to apply to situations like this. Because imagine like if I was writing code based on somebody's choice of a state in an app, would you want to write if state equal Wisconsin, else if state equal Illinois, else if state equal etc. You know, and then just go all through all the states. Oh my God, is that a nightmare? This is a lot easier to write. For one thing, I also think it's a lot easier if you have multiple things you have to choose from. That it makes it a lot more efficient and direct, right? It's a different, more advanced type of if statement. People who do a lot of coding and come on these situations like this will always go to a switch statement first before they'll do a if, else if, etc. Because the if, else, if stuff takes a long time to code. This goes a little bit faster. I don't know if you guys are seeing that, but if you're in the process of doing it, you'll see exactly what I mean. There are some efficiencies to how you can write it. There's the stacking, right? That helps. I think if the statements are really simple, you can put them all in one line like that. So if I have like 50 possibilities, they're really easy to go through them, I think. So consider those as your possibilities. Any questions so far? Are you guys good? Fantastic. Right. Let's move on. I'm going to try to get a little bit into this next section here, and then we'll take a little break here in a little bit because we've been going for a while already. All right. So the next thing that we're going to talk about are local functions, and you're going to hear this terminology from all of your programming teachers, by the way, and I'm one of them that will kind of use these terms interchangeably. And if you already know how to code, you probably are already hearing these terms interchangeably. But basically, what a function is a named block of code. So we give it a name, It's possible to send values to it and receive values from it, but is a named block of code inside curly brackets, and I can execute that code by simply calling it by name. Guess what? We've already been doing it. We've been using what we call global functions right from the beginning. When we do write line, and you notice how that's put together, it's called a name, it's got a couple of parentheses. That's a really clear indicator that it is basically a function of some sort, right? When a function is standalone, we call it a function. When a function is built into another object of some sort, we call it a method because it is subservient to the larger object. But really, if you ever hear that terminology, a lot of us programmers very intentionally and mistakenly at the same time will use both terms. There really is a correct way to do it. But if somebody says a method or a function, they're kind of the same thing because they really are. It's just a matter of what structure they're part of, right? So please keep that in mind. All right, so let's look at the definition here. It says a collection of statements to perform a task. And more importantly, they have a name, right? Okay, so it says use to divide and conquer. You can break a problem into smaller manageable pieces. And when you kind of, operate in this way, the code also becomes reusable. So if you have like a thing that happens a lot, like write line is a great example, right? You don't have to reinvent the code that does it. You just utilize it. So once you've put in the hard work to create it, now it's in your arsenal of tools. It's in your toolbox, and all you have to do is grab it and utilize it. The other advantage is because we are designing the code and naming it and usually putting it somewhere out of view, sometimes in external libraries, for example, it makes our code more readable. Because, like, for example, if I look at like a write line command, I really don't know how this operates. And there's this concept that we use when we create functions. We call them functions are kind of like a black box, right? So for example, if I'm driving a car, I really don't need to know how the combustion engine works on a micro level in order to sit in the car, turn the key and go. Now, if I have a problem on the road and it breaks down, it might be helpful, but chances are I'm not going to take off the cylinder head and redo my pistons, out on a roadway. That's probably not going to happen. But that's kind of how write line is, right? There's some sort of a magic sauce there that whatever I'm feeding into those parentheses is putting stuff up on the screen. I guess I kind of don't care how it happens. Kind of the same way we don't care how turning the key in a car makes the motor go. But we still can utilize that to get to where we're going, right? So, a function in essence sort of becomes sort of like a black box. Is kind of a good way to think about it. All right, so now they're kind of making this point here. It says that C# has methods and local functions. So they exist inside of classes. So we have the example of read line in this situation. Methods exist inside of other classes. Classes and objects are fairly synonymous. And just to kind of describe the difference, and we haven't learned about classes yet, but a class is the definition for an object, and an object is the instantiation or the realization of that object. So for example, my blueprint is is to a class, or a house, what a class is to code. Right. So for example, if I have the blueprint for a house that isn't the house, but it sure describes how that house operates and what's in that house and what shape it is and how tall it is and how big the rooms are, every little detail. The house itself becomes the object when an object is created and that object travels with internal functions, which often happens. We call them methods. So read line in truth is a method, right? It's a method of a class called console. And this is, kind of real fascinating about programming is I can tell just from looking at this as a snippet of code, console is a class, or an object of the class, and readline is a method of that class. It's available only through console. Pretty cool, right? Eventually, we will build our own objects and classes, and you can create your own functions, and you can name them whatever you want. And to the user, they don't care what's inside as long as it works. Right. Now, when you build up stuff like this, we also refer to it, informally, well, not informally, but formally as an API, application programming interface. Readline and WriteLine are basically tools that we use. We don't care how they work. It's kind of like pushing the button on the dashboard, to make the wipers go. Right. Same kind of thing. Local functions, by contrast, are methods written inside of other methods to be used only by the outer method. Okay, what does that mean? When we're writing a program, and see, we've kind of obscured this as we write a console program. So here's what I'm going to do is I'm going to close this one. Let's go ahead and just close that solution. I'm going to create a new project. And normally when we go through these screens, right, we get to this screen and we usually leave this box unchecked, right? Because if we check it, so I'm going to do that. This is really what's happening underneath in the program. And we've been doing all our coding inside this set of curly brackets, but the way that we're proceeding, all this other external stuff is obscured. But truth be told, it is there when we compile the program. So what they're telling us in that slide is every program that we execute is operating inside what we call the main method of C#. Now, anybody who's ever coded in Java, right, and you guys probably will get a healthy dose of that too. In Java, this is where we start. We learn about a class, we learn about the main method, and just like C#, anything that's going to execute in a program has to happen inside this main method. Now, here's where the complexity comes in. If I create another function, I would create it typically on this level. So I would actually come in here and create a func, and that's how we do it. We create a func, and then we define it here in this spot, and then we give it a name, and then anywhere inside this set of curly brackets, we can access that function by name. That's really what they're referring to here. So when they say, local functions are method written inside of other methods to be used only by the outer method, this is what they're referring to. You can't get that perspective unless you look at your code like this, right? So I'm going to kind of flip back and forth between these modes so you understand that, when we're obscuring all this external stuff, it is still actually there, right? And so when we start writing our functions, this is going to become relevant. Right? And it says the program CS file has a hidden method called program main that our code gets placed into when it runs. All methods that we will be writing in this module will be local functions, meaning they will be internalized so we can access them. When we're using the console WriteLine, we're using external libraries and external methods. When we create them ourselves, they are local. Now, why? Why do we bother with this? Well, programmers are clever. So programmers very quickly figure out, hey, if I'm doing a task repetitively, let's set it up so I don't have to do it again, right? So if I figure out how to do a WriteLine, why would I rewrite that code every single time? It's silly, right? Absolutely silly. Right? So the major point, I think, really of working with functions is basically this. We can perform the same task over and over again really easily. Don't have to rewrite it. And sometimes it's actually really efficient to create it locally, or sometimes it's also efficient to create it externally. It just depends on what the scenario is. But if you do create a local function, it usually is intended to serve the local code, right? Yes, and it does actually happen over time that you will develop your own library of functions, believe it or not. All right. So let's also talk about this other concept that we haven't really looked at yet, and that is this concept of a local variable. Because when we start dealing with, like putting code into blocks that are named, and we have multiple sets of curly brackets that we're contending with, when we create a variable, that variable is only valid inside that set of curly brackets. So when I'm running a program that looks like this, and I create a variable, here, whatever that happens to be, right? And we'll just go with whatever, right? This variable is only accessible from within this set of curly brackets. So it's a local variable. And then we use this keyword scope, that it's only in scope when it's in this block of code. Now, if I create a variable outside the main method, we would call that a global variable for the program. So what we're implying here is that we're going to write local variables. And often when we are creating functions, by the way, we will create variables that only operate inside the function. But then we'll also learn that we can access variables outside the function as well. And that's where we'll start talking about by reference and by value, but that's coming. So fasten your seatbelts, right? I think we're at the point, really good spot to take a break right now. So let's take like a 5 to 7 minute break. Let's come back at around 8:06. Pause the recording. All right, we're back from a break and we're going to continue on. We were just talking about local variables, and we're going to get a whole bunch of examples of this coming up in the slides. First of all, let's take a look at the main method and really how the C# programs truly work in the background. It's kind of a really interesting aspect. Now, if you're looking at the code that's on the screen, and if you did the same thing that I did before, and you actually look at C# and how it does it's not exactly like what you're seeing in the slide. So I feel kind of compelled to point that out. Like, for example, in the slide, it just says class program, right? It doesn't have this internal thing, right? That's kind of like a later addition. Also in what we call the main method, by the way, that's the formal name for it, we see these really weird cryptic preface words that actually have very special meaning in coding. And I'll tell you what, like whenever I think about like some of the early days of working in this style of language, I was like, holy cow, man, I got to memorize this like static, void, main, string, square bracket, args thing. Yeah, and when I first learned how to code, we didn't have autocomplete, and when you spun up a new program, it didn't automatically create that for you either, so like it was like you always would have to start from scratch, but you still had to add the required pieces. So we would have to build a class to hold everything, and then the main method. And what's kind of fascinating about at least this part of it is that this is kind of been the way that C style programs have always operated. You have a class, and then you have a main method, and generally how this works is the class is your program. That's really what your program is the class, and then the main method is the part of the class that actually executes code. So if you don't put it inside of here, the code doesn't run. So I could create a bunch of code and put it down here, for example, but it would never ever execute unless it's put in here somehow. Right? So think about that, right? So the main method really drives the whole program. It's kind of like the motor is running and this is what gets it down the road. In later years, and I say in later years, so like 5, 6, 7 years ago, Microsoft started adding to all of their C# programs this external structure called a namespace. And a namespace, very simply, if you're curious, is just simply a container to hold your other code. It also allows for you to have multiple class structures inside the same namespace, whether they're inside the same file or an external file that has the same namespace. And it adds another layer of nomenclature to it. So like, for example, this is just being called program, right? Or the console app or whatever. But this is where the naming kind of builds from. We look at each level and then we add kind of like the dot notation to build into the piece that we need, including the methods that we're about to learn about. But that namespace piece is pretty fascinating. Now, when you look at this slide, you notice how they're kind of like leaving that internal thing off of here, right? But all the rest of it is basically the same. That internal thing, by the way, is optional. You can actually remove it in most situations. The other thing that we're not seeing in our code is this, because this these days is now implied. But in the old days, if I wanted to do something like, for example, do a write line or a console output or whatever, I would have to first add this, which is a call to an external library that then I would be able to extract the methods out of it and use them in my program. And so when you write really complicated programs, you're often using external libraries, either ones you've created or that are pre-created or are part of some fancy framework, which is really common, or an API, for example. And then you might have a whole list of stuff at the top. You might say like using web, using user interface, using, and you're importing all those libraries and all their capabilities so that you can save time writing code, right? So as you write more complex code, you'll have more using statements. Right now, we're super basic, but that will change, and it will change quickly, you know? So, so that, I think that's really kind of interesting. Now, when we have been writing programs, and I mentioned this before, this is where our code's been sitting. And I didn't mean to italicize that, but right here where the comment sits, all the stuff that we've been doing so far is basically in between those curly brackets, but all the higher level and lower level stuff is obscured from us. Now, when we start to think about the stuff that we've been doing and we put it into that framework, right? You know, basically we're operating inside the main method. If I start declaring variables in like any of the code that we've done so far, you know, anything that's inside that curly bracket is considered in scope, and that variable is only valid inside those curly brackets. And I know I'm repeating this a lot, but it is really an important concept. Because when you start working with that greater structure and then you're trying to pull a value in for something, and you're like, why isn't it working? Right. And the answer generally might be it's out of scope. It's really the answer. If we do this comparison now, like if we look at an if block, right? So like how an if statement's put together, and this is an if statement that's got more than one statement inside of it. And I go ahead and I declare a variable inside that if statement, and then I try to access that message outside of it. Well, this is only in scope inside the curly brackets. So now we have a little bit of a problem. How do we get it to become in scope or out of scope so that we can actually properly utilize it? So it's not a small issue in programming. So this is very important, especially in languages where we're using the curly brackets. But it really applies to even like languages like Python, which I know some of you are going to be taking that course. And Python's really fascinating because you don't use the curly brackets at all. Remember, I told you like indenting does the whole thing. So let's read what this says. It says, when the program enters the if block, the variable message comes into scope. When the program exits the if block, the variable message leaves scope. That's the terminology that we use, right? So it's in scope, comes into scope, and leaves scope, right? So you can't use a variable outside of its scope. So if I try to, you know, access a variable that isn't inside the curly brackets I'm working with, I will get an error message. It just won't run. That's a problem, right? So you have to figure out your way around it. And you also can't have two variables inside the same set of curly brackets with the same name. They have to be unique, right? And that's not something we've really played with a lot. But boy, it'll underline for sure. You know, if you have that issue, that formatting will kick in. So if we're going to go ahead and start to define a function, um, you know, we have this terminology that we use. So we're going to kind of like build this up really slowly. But first thing that we do is we have the header for the function, which basically defines it. And then we have the body of the function, which is the curly brackets and everything inside, right? So the header is basically kind of like the declaration. And then the curly bracket part is the actual body. You kind of think of it like a document. It's got a heading and a body, right? And if you guys are web people, that might resonate a little bit more, right? So in this case, this is kind of bizarre because we're not using the function keyword here at all, but we're using void. Like, okay, that sounds really meaningful. And what void means in this context, we'll learn about this in a second. It just very simply means that if a function is void, it doesn't return a value. It just executes the content. So think about this. If I'm doing a function that I call by name and it just outputs text to the screen, it's not really returning a value. So then it therefore is void. Conversely, if I'm running a function that returns a value, then I indicate what type of value it's returning to the rest of the program. So I might run a function that takes a bunch of inputs, maybe even prompts the user, does some math, does some calculations, runs some if statements, whatever it does. And then at the very end of it all, it sends a value back to the program for further processing or display, right? The value that it sends back would then be indicated in this spot. Now, let's compare that to what we have here, right? So here we have the keyword void. So now all of a sudden we've demystified one of those words, right? So now it's like not that strange. So whenever you see void in a method or function call, it just means this isn't returning anything. That's all it means. It's not returning a value to the rest of the program. It just is what it is, right? It's just doing what it says. If this was replaced with some sort of a data type, integer, string, double, etc., that's what it's returning to the rest of the program. Yes, the word in front also has a special meaning. We'll get to that. You don't worry about it. Right? But static basically means it's not changing. If you want to plant something in your brain. All right, so void function does not return a value. Any data type, function returns a value of the specified type, cannot use var for the return type. So you can't say, you can't use a keyword. We're not declaring if it's a variable or not. That's preset. We already told it what it's returning. Now, here it says the void method or local function performs a task, then terminates, right? And this is what I was talking about before. So really common. So look at what this is. Just you can assume what it's doing. We got a write line says hello. Okay, then it displays something that's formatted already, and then it runs a print menu. So for example, once again, this is a black box. We don't know what this means or what it does, but I can call it and it'll do whatever it does, right? I assume it's going to put something on the screen. And this looks like it would probably, I don't know, print a menu on the screen, like choose one of the 5 options, for example. But if I had a method that was returning something, I could not just call the function like this. This is the fascinating part of it. This would just execute the tasks. If I was returning something, then I would need a place to put it. So that's what this slide's about. So for example, if I run a piece of code, and we'll use an example of a pre-built method. Here's an example. I have some variable somewhere, price. I'm converting that to an integer 32, right? So 32-bit integer, right? So we're pulling from the convert class. We're running this method that turns it into an integer. And then what's happening? This method clearly is returning a value. What is it returning? Price converted to an integer, and then it's storing it here. So this method is therefore returning an integer. to store it, I have to put it in an integer. So this is a clear indicator that the method being called is returning a value. A method that is called, or a function, excuse me, that is called, that isn't being added to a variable or some other structure, is just executing some code. There's no return. Right? So I think that might help. If you look at the next one, the string, once again, here we have response to upper. And so maybe this is a variable that's a string. So all the string methods carry with it. And then to upper converts it to uppercase. That clearly is returning what? A string, but in uppercase. And we're going to need a string to store it. So telling us very clearly, to upper is a method that returns a string. Right? So you need to know these things, because if you're grabbing values from methods that you didn't create, what kind of value are they returning so that you can utilize it correctly? Okay. All right, let's keep moving on here. The other thing that we start to think about is when we start creating functions, and functions basically do things, and sometimes collections of things. And because they do things, I think of them as actions basically. And so we use descriptive verb style names. So for example, if our function prints out a menu for the user, well, why don't we call it what it does? Print menu. Or, what was the other example they had up above? Display formatting. Once again, you can see that's kind of like a verb, right? There's also this format, and this is a C# convention, by the way, that you name your functions in what we call upper camel case, meaning kind of like we did with variables, right, where the logical words start with a capital, but the very first word starts with a capital too. So first letter is cap, next logical word is cap. So that's called upper camel case. And there's also known as Pascal case. And here I'm going to date myself again. That's the very first programming language I ever learned, was called Pascal. And by the way, it was considered a learning language and not a professional language, which is like, why did I ever learn it? But actually, it was really a good experience for me, right? Because here I am, obviously. It must have worked, right? So John, you were smiling on that one. You have experience with that one too?
I wrote in it, Fortran, a little bit of
Okay.
basic. You'll learn lots of languages in your life.
Yes, yes. And you know what? When I was a young man, those languages were the prominent ones: Pascal, Fortran, Basic, COBOL. We also would code in assembly, and then C back then was like it wasn't a new language, but it wasn't like the commoners language. It was a powerful language, by the way. All right. We do have the same rules that we use for naming methods and functions that we do for variables. We can use numbers, letters, and underscores, and we can't start with a number. So keep all those in mind as you're naming things. The general way that you normally see it is that upper camel case followed by a set of parentheses, right? The parentheses are the clue that this is a function, right? Either that you're using one or you're creating one. Now, interestingly, when we start to, call functions and methods, sometimes a function can operate, for example, let's go back to this, like the print menu is probably just a series of console write line statements, option 1, Wisconsin, option 2, Illinois, option 3, Alaska, whatever. So nothing needs to be sent to that to make it happen. Other times, though, your function requires information from the rest of the program in order to be able to execute what it needs to do. So for example, if I have a function called sum numbers, well, that's pretty clear what it does, right? Because the verb is really well defined. It's going to take whatever numbers I send to it and sum them. It's going to add them together, right? And in this case, when I'm sending in values, look at kind of how this is put together. inside the parentheses, I'm declaring the data type of what I'm sending and a name for it for internal use. So in other words, I'm declaring a local variable here is really what I'm doing. So internal to the function and its curly brackets, I'm setting up an integer called num1 and an integer called num2. And when I send the information to the function externally, I would do something to the effect of, I would say sum, actually, make sure it's the correct case. See, I'm typing with my thumbs here or something. If I would call it externally, I might like hard code values like this. That would work because they're integers, correct? Or I could send in variables like, n1, n2, assuming they're integers, right? That would be how I would call it. Of course, semicolon at the end, right? Now, we don't know if this actually returns a value. I would probably assume it actually returns a value, but we don't know that for a fact. Right? So the stuff that we're putting inside the parentheses is called a parameter, right? And real frankly, here's kind of another terminology point, and this is important, right? When we throw stuff into a function, we are passing parameters is how we use the terminology, but we can also call those arguments. And depending on where you place yourself in the code, both terms can be correct. So you very often hear this interchangeable language of a parameter or an argument. And basically what that means, the stuff inside the parentheses that you're sending to a function or a method. So your parameter or argument. The doesn't mean that we necessarily in this situation have to send something in. It depends on what the function does and what it requires. This one clearly requires it. This one does not, right? So we don't need to send anything in. It's just going to do the work. And you can kind of tell what this one's going to do. It says print the times table. Okay. That sounds like a functional task. I don't need to send it any value for it to create that. This one, if I'm summing numbers, right? Well, that's going to add them together and probably return a value that's an integer, right? If I add an integer and an integer, it returns an integer. Makes sense. This one, it's not returning anything. It's void. So hopefully you're like starting to pick up on the terminology now. All right. So here's the other aspect of this. We'll start to write a little bit of code here. And we'll see this on the next slide. But when we create a function, here's kind of the weird part about it. You can create the function and then it does nothing. And then you're like, but Ty, I created it. Look, here's my code. I created the function. I'm like, you sure did. But it's never going to run because you never put the key in the ignition and turned it. Right. So in order to put the key in the ignition and start the car, make it go, you have to actually call the function from your program. So there's one task is to create it, and the other task is to actually use it, right? So you may have built yourself a hammer or a saw, but now you got to pick that tool up and actually utilize it. So, in this word call, right? And this happens a lot, right? The program calls a local function by its name it's needing. Calling means we will execute it, run it, invoke it, whatever. You can think of kind of that as sort of like a noun. And I think that's really kind of a nice comparison, where the name of the function is the verb, but calling it by name is like referring to somebody by their proper, surname or whatever. You're calling it, you're bringing it forward. Let's take a look at this really simple little program here, and you'll see what I'm talking about. So assuming all of this is inside the main method, right? So I have a console write line, and it puts this up on the screen, and then it calls display message, right? Display message is void. It doesn't return anything, but it will just execute this code. Yes, I realize you could just take the line I highlighted and put it right here and it would do the same thing. But what if this was, displays the names of all 50 states. Oh, that would be cumbersome. I wouldn't want to have to rewrite that code every time. Right. So this could be a bunch of messages. So it hits this spot in the code. It's calling the function. It looks in scope to see if it can find it. If it finds it, it does whatever task is listed here and then comes back up here and executes the next statement. So if I were to take this code, and you know what, let's take this code and let's just actually do it. Let's put it inside here. I'll just paste it in. Let's run it. And then you should see before call, right? In display message method after call. So you see like what it's doing is the only way that this function executes is if I call it. If I do comment it out and run it. So the code is there, but it does not execute unless I call it by name, period, right? So I think that's really kind of interesting. So this is a really common beginner programming problem, and real frankly, and embarrassingly sometimes, so an experienced programmer problem too. Like you spend all this time creating your methods and your functions, and like, I don't know what's going on. It's just not working, right? And I've seen people do it, and I'm like, did you call it? Oh, darn, I never called it. Never asked it to, I never put the key in the ignition. Why isn't this car going? Right. So that's a really good example. I like that example a lot, right? Resonates with people. But that's a really good example. So you got to call that function. You got to make sure that it runs. That's pretty cool. All right. We're going to keep going here, and then we're going to do a little bit of coding when we get through these slides. We only got 20 more to go. Right. All right. I know you guys are probably getting a little bored with it, but here we go. Now, this is kind of interesting because what they're doing here is they're kind of talking about this concept of layered local function calls. So function A can call function B, which calls function C. All right, so let's take a look at how this would operate. Here at the top, I have a function call. All right, so if I'm calling a function, that has to exist somewhere in my code. You know what? Level 1 exists right here. What does level 1 do? It calls level 2. All right. Well, what does level 2 do? It calls level 3. What does level 3 do? It does a simple write line, hello there, or hello world, right? Like back to day 1. And so what does this output? Yeah, and here's the other question. Would this work? Okay, well, here's the beauty of this. You can actually grab it from the slideshow if you want, right? And you can just drop it into your coding tool, and there's all that code we were looking at. Let's run it. Does it work? Yeah, it sure does. There's a little bit of a misconception here because we are talking about variable scope, right? And so you get in this mindset of like, well, if I have a variable inside curly brackets, I can't use it outside the curly brackets. But here I am inside of curly brackets calling a function that's not inside these curly brackets. So that tells you how functions are a little bit different scoping wise than variables are. As long as you're basically in the same level of external curly brackets, I'm talking about these with the main method, all of these functions can call each other. And yes, it is perfectly acceptable to write a function that calls a function, that calls a function, that calls a function. That's totally allowable, right? It's all in the conception, of course, as to what it's actually doing. That's a separate issue. The grander point here is that one function can call the other, and it can be layered in really clever ways. And it's not actually not unusual. It's very, very, very common. All right, so we talked before about the concept of a parameter. Now we're talking about passing arguments. And once again, arguments and parameters are really pretty synonymous in terms of definition. It's all relative to where you're looking at it from. And so it says arguments are the values that are sent into a local function or method. So for example, when I send hello to write line, that's an argument. And it's okay, by the way, that you refer to it as a parameter as well. technically the parameter is really relative to the inside of the code, like when I'm inside the function. So a function receives a parameter, but if I'm sending a value to a function, it's called an argument. And believe me, folks, professional programmers get that wrong all the time. Most of us, like we use method and function interchangeably, we also use arguments and parameters interchangeably. But there is actually a correct definition for both, right? Nobody really cares though. You know, like in the real world of coding, if it works, it works. It doesn't matter if you call it an argument or parameter, as long as it's what's inside the parentheses is kind of a good way to look at it. Now, the kind of interesting thing here is, I like this statement. It says the ability to pass different arguments makes the method versatile. So you can, if you set up your method or your function intelligently, you can use it in a lot of different scenarios, right? Sometimes you can't, like, you know, like let's say if you're performing math or something, you know, it's going to be fixed. Like you're performing, let's say, the volume of a cylinder. You're going to send in a couple of parameters and that's all there is to it. You know, it's going to return a value. There's not much you can do to it. Right line, though, is one of those that's really powerful that we've already discovered because it can do math. It can put strings on the screen. It can put numbers on the screen. It can string interpolate. It can do all sorts of stuff, right? So it's actually a pretty powerful one and very, very, very versatile. Now, we did actually learn some of these formatting commands. I don't really focus a lot on them because, you know, ultimately when we start putting stuff into GUI programs, we don't necessarily use this sort of approach. But this string interpolation technique, if you guys remember, this is actually a predefined format to display currency, right, in the format of something before the decimal point with a dollar sign, right, and a period, and just 2 decimal places. That's a currency format. Very, very common. And you know what? There are ways where you could write your own method to do that. So in other words, I could create this display currency method for myself and use it in my own programs. I don't know why I'd go to that trouble, really, but you could, right? There's nothing that says you can or cannot. Right? Now, let's look at what they're trying to point out here, and that is amount here. You notice this is a double coming in, is a parameter variable. So that really truly is declaring a variable inside this block of code. So where is this valid? Here, right? The fact that it's inside the parentheses means it's expecting something to be delivered to it by the external function call, right? And it's declared inside the parentheses. Now, if we were to utilize this function, right, and you'll notice this is kind of interesting because they're like hard coding a mathematical operation here, like 14.99 times 7 times 1.055. I know what it's doing. Do you guys know what it's doing? All right, so let me explain. Somebody's buying 7 things that cost $14.99, and then they're adding the tax to it. That's what this is, right? So if you really, you know, think about it. Okay, so hey, wait, I thought the tax was only 5.5%. Well, it depends on what county you're in, but in this case, why do you use the 1? Because it adds back the value that you're originally adding the tax to. So it gives you the 7 items with the tax in total, right? But we want to display that as currency, right? So we would feed whatever that mathematical result is. And I wouldn't normally hard code math in there, but you can do it, right? I'm just putting that as an aside. But whatever that calculation results in will come in here. And because we have 2 digits and 3 digits after the decimal point, I mean, we could get really weird, you know, digit answers after the decimal point. So converting it to the currency standard of just 2 decimal places is important, right? Because I can't really ask somebody for a fraction of a penny, I guess, unless they're buying gasoline, right? Do you guys ever like wonder why is gasoline priced like that? Like 399.9, right? Why it's $4, right? So you should know that. But I think it's a pretty interesting thing. But this, whatever's inside the parentheses, doesn't matter what it is, will get transported to this variable. Needs to be in the correct data format. Transports into the function does its work, and we call that a parameter. So from inside the function, it's a parameter. From outside where I'm sending it, this is an argument. You see the difference in the terminology? Now you can summarily forget it. Don't latch your brain on that piece, you know. I'll tell you what, that concept took me absolutely years to wrap my head around. I'm like, some people say argument and some people say parameter. I just don't get it, you know. And it's no embarrassment, right? If you don't latch onto it right away, that's fine. Let's kind of show the follow through on this now. So the argument can be kind of in any format that's valid. I don't know if you guys have picked up on this yet. So for example, if I set up a double called subtotal and I do some math and it's displayed here, right, stored there, I can send that in. But I can also take that and then add additional math and send that in. That would work too. Or I can just hard code it. This would be a literal argument. So all of those would work. Every single one of those would work. There's kind of no right or wrong, as long as whatever's inside the parentheses is of the correct data type and is compatible with where we're sending it to. If it's not, you'll have to do a conversion before it goes in. That's something to think about as well. Well-written functions will do the conversions internally if they need them. That's kind of an interesting thought. So, all right, so let's read this. It says an argument's data type must be compatible with the parameter's data type, just like when storing a value in a variable. Okay, makes sense. C# will automatically do a widening conversion, example, integer to double. So if I send an integer into display currency, which really is expecting a double, it will still work as long as we're moving upward in complexity. If it requires an integer and I'm sending in a double, well, that's a little bit different, right? To perform a narrowing conversion, so to go the other direction, now you want to actually do a conversion. So here we have a double, we're storing it here, and then we want to send it into this other thing that's expecting an integer. It will not take a double because that's a narrowing of complexity, not a widening of complexity. So it becomes necessary to do that conversion. So here comes that conversion, and we do it. Yeah, you can do it right inside the function call if you wish, or you could have a separate statement that does the conversion and then feed the variable. It doesn't matter, right? Ultimately, you're still running this conversion one way or the other because this requires it. Otherwise, it will not execute. It's as simple as that. All right, let's take a look at this next slide here. So when you're sending stuff into a function, you also run into this other situation that happens. And you know what? I'll be real frank with you. There's many different ways to look at this situation. And, you know, I have my certain best practices I try to preach upon people, but they're not rules, you know, so there's going to be some suggestions for me to keep things straight. But basically the point is that when you're sending something in, it doesn't have to have the same name externally from where it's being called to what it's being turned into when you send it into the function. So for example, if I'm taking this 5.0 and putting it in num and I convert that to an integer and then send it in, it's still going to land inside this variable called amount. So wait a second. I called it num out here, but here I'm calling it amount. That's okay. Yes. Because really it's kind of like passing the baton. It's like, well, I'm calling it Henry. I'm calling it Frank. You know, it doesn't really matter what you're calling it. It's still the same information that's traveling. I do see a lot of programmers doing this, and this is way more common in Python, by the way, for whatever reason. Python programmers do this all the time, where this would be called num also. Right? So you're sending it in there, that variable there is called num, and it's like, wait, this one's called num too, and it's called num inside here. It doesn't matter. It still works. And by the way, you can do that in C# too, but I won't like it as much. It might even suggest that you change it. And some programmers really just do that because they're just not clever about what they're doing, or maybe don't want to put in the extra effort to come up with a new name. But here's what happens to me when I'm coding like that. Now I'm losing track of like, well, num is in scope outside of this function. And then if it's named the same thing here, then this num is only in scope inside of the function. But then when I'm looking through my code at num, I'm like, I'm not sure which one I'm looking at anymore. You see the confusion there? So I'm a really big fan of making sure I use different names internally for a function than I do externally for the stuff I'm sending to it. Yeah, and Alex, I see you nodding. It really is smarter. Okay, so fair warning, Python people, right? When you learn Python, Python programmers tend to do the opposite for whatever reason. It drives me nuts, because I've learned like these old school ways, and then yeah, it doesn't matter. It works. Yeah, it works. Okay, it works. That's kind of the modern mindset. Hey, it works. Don't mess with it. All right, so they are trying to like kind of step through this scope issue. Really, the parameter is a local variable to the function. I think we figured that out already. It is scoped to the local function, so it's only valid here. And you can only refer to it by name inside the function of the body. Makes sense. If I name it the same, then, oh my God, confusion will abound. Guaranteed, right? Especially if you're using that variable name a lot. It is possible, we already saw this, to be able to send in multiple values, each with its own data type declaration separated by a comma. Is there a limit? Can I only do one or two? A common question. No, you can do as many as you can conceptualize and type in, right? I think there's kind of a functional and practical limit to that. I'm not sure at what point I would say that, hey, this function requires, 20 parameters. That might be really kind of hard to kind of wrap your head around. Usually, if you're sending in that much information all at once, you usually switch to a different data type, like a complex data type that can hold multiple values. We haven't learned about those yet, but we will. Right. So in this case, we're setting up two variables that are local to the function, num1 and num2, both integers, which transport here to do the math. Now, I cannot do shortcuts. So like, I don't know if you guys like think about like when you do a variable declaration, like I can take that, put a semicolon at the end, and that's valid, right? Like I can say int num1 comma num2, and just proof of concept here. Let's go back over here. If I just declare, a combo declaration like this, that's okay. I don't have any values in there yet, but and actually I could go num3, num 88, whatever. It doesn't matter, right? It's just easier than doing like int, like one at a time. What they're trying to warn you about here is you cannot do that in a parameter list. You must individually declare each one in its data type. So this wouldn't work here. Each one has to say int num1, int num2. I'm sorry, that's just how it works. No shortcuts on this one. So now, if we're going to send in more than one value, let's be 2 values, 3 values, whatever, they will go in order that you're sending them. So if I want A or 5 to go to this position, right, and B to go to this position, I should send them in that order. Otherwise, if they end up doing different calculations and I flip their order, it doesn't necessarily mean it'll work correctly. So order does matter. And in some cases, and we haven't looked at an example like this, maybe the first one's an integer and the second one's a double and the third one's a string. So I can't put the string in the first position. See what I'm saying? They have to be in the right order, the same order they're expected to be received. Now, in this case, once again, just like with the previous example, you just basically put them in order, comma to separate them. Convention is you also add a space in between, but it's optional. Yes, you can do math in in position. Yes, you can hard code literals and do math. And negative values are perfectly valid as well. So all of these would be valid ways to call that function. All of those would work. I'm not always the biggest fan of doing math in the statements, though. I'll tell you that. But you know that's kind of dependent on the situation, frankly. All right. So here comes the indoctrination here, right? So you guys can memorize this. Yes, it does differ amongst languages, but there is actually a correct thing. Okay, so arguments are passed to parameters. So once again, here, these are all arguments because I'm sending them to the function. While here, these are parameters. Even though this one's incorrect, that would be a parameter. Right? So APP, arguments are passed to parameters. Got it memorized? All right, whatever, don't worry about it too much. Right. Next, let's talk about, this is kind of an interesting thing too. It says local variables only exist while in scope. Okay, what does that mean? Okay, so here's what that means. If I come up and I look at this function, and let's look at the correct version of it, this one, right? This is the correct version. If I'm calling this externally and I'm sending in, let's say, the number 5 and the number 6, right? Those are now integers that were stored in these variable names. Spots were created in memory. Those memory positions are called. We do a little bit of math, and then we do a console output. When this code is done running, those variables have disappeared. That's what that means, right? They run for as long as they need to, and then they go away. So it says local variables only exist while in scope. All local variables and parameters are destroyed when a local function completes. Now, there's a reason for this, right? If I was writing a program and I created like thousands of variables, I'm occupying memory. If I don't release the memory, eventually my computer will just choke and crash, right? At some point, I need to free up the memory that I was using, if I'm not using it again, so that the computer can keep operating optimally, basically. Since when a local function is done running, the memory holding the variables is reclaimed. Now, what's really fascinating about this particular feature, and this is a kind of historical artifact of programming, right, that you guys don't have to worry about. What this really refers to is this thing that we call junk collection, right? And when the Java programming language first came out, and this is in the early 90s, I think, when it first came out, it was the first language that we had that did automatic garbage collection, junk collection, right? Meaning I would create a variable, I would use it, the program would stop running, and the memory is freed up. Believe it or not, in the old days of like C programming, like when I first learned it, you would have to create a variable, utilize it in your program, and then you would have to destroy it. And I forget what the command was to destroy it, but if you didn't free up the memory, then you would have other problems on your system. So that was like manual garbage collection or junk collection. Usually they call it garbage collection in most languages. But that's what the concept is. And it's an important concept because it makes modern programming a lot simpler. Can you imagine, like, if you had to create like 500 variables in a program, then you'd have to write code to destroy those 500 variables and free up the memory? I mean, how cumbersome is that? Somebody got smart and wrote a function probably to take care of it for us automatically. Thank you. Whoever came up with that idea, thank you very much. All right, so let's read about this one. This one says value returning local function. When data goes into local functions through parameters and arguments. So like we will send it in, right? We've learned the difference now between a parameter and an argument, stuff inside the parentheses. But if we need to pull data out from that function and the local variables are destroyed, what happens then? We didn't talk about that scenario. Well, there is this capability of functions that can pass back or return a value as they exit. And it very commonly the whole purpose of a function. So a function can just simply execute a task. This is back to the early slides of this now, right? Maybe a bunch of write lines, right? Just does it and it's done. Empty parentheses probably. More common though is when we're sending stuff into a function, very often we're expecting something to come back, like summing numbers or averaging numbers or determining some sort of a value. And then we use a return statement at the bottom of the function to send the value back to where it was called. And whatever this item is, its data type declaration is here. This is really kind of bizarre. So what are we returning? We're returning a result. What is result? It's an integer, right? And if the return value doesn't match the data type expected on the return, we have a problem there too. So if this was a double here, this wouldn't work. Then that would have to be changed to a double. Or if we were dealing with a string here, that would need to be changed to string. Now, interestingly, by the way, you can have even more complex data types placed in those spots. Including right down to the point where you're passing like full objects back and forth in complex data structures like arrays and matrices and things like that. In this really simple example, we're sending in two numbers, integers, we're adding them together, we're storing them in another integer, and then returning the result, right? Returning is really pretty darn important, in functions very often, right? So it says typically, and I'm going to say typically, it's the last statement of the method or the function is the return statement, right? Right? The returns a value of the local function's return type, which is this. If it says void, remember, it's returning nothing. So you can't have a return statement. If you have a data type as that first declaration, then that's what it's returning. So interestingly, when we're running a function like this, right? So this is the sum function, right? So we might have 5 apples and 7 oranges stored in these two variables. We run the function, but because the function is known to return a value, I can't just list it like I have in the highlight. Because it's going to return a value, it's going to have nowhere to go. All right. Here's kind of a real primitive example of this. Let's go back to the previous slide and let's actually grab this code. And I think this will be helpful in understanding. Let's just drop that into our program here. Just like that. So here's the function definition. And then we're going to just copy this other code. And I'm thankful that it's text. Sometimes I get these PowerPoints and they're images, by the way. And then you can't copy the text, so it makes them kind of, not very helpful for coding. And then here's another question. It's like, do I have to call this from above the function or below the function? Here's the answer. Doesn't matter. The general rule in programming is, though, we put all our functions definitions at the bottom, and then we call them from the top of the program. Because you might not need to ever go to the bottom and look, is kind of the thinking. So here we have int apples, write 5, int oranges 7. We call some apples and oranges. It stores the value in fruit. So the return value is going to go in here. Let's run this and just make sure it works. What should the output be? We didn't tell it to output anything. It's doing exactly what we told it. Kind of interesting. Well, how about this? What if I create a new function? I'm going to make it void, by the way. It's not going to return anything. And I'm just going to call it display result. Real common name, by the way. And what would this kind of look like? Yeah, console write line probably makes sense. And what should it display? Fruit. That should work. Let's put a semicolon at the end. So will this work? Will this display function work? Why or why not? Okay, here's the why it won't work, if you're wondering, right? I never called it. I created it, never called it. So if I do want this to run, let's just call it by name. So I'm going to say display. It should find it. See, it's finding it. And then I put in my parentheses and my semicolon. Now this is void. It's not returning anything, so I don't need to store it. Will this work correctly? Let's try it. It does. Now this is kind of interesting. If a variable is in scope inside those curly brackets, why is this able to see that? Here's the answer. Because this inside these curly brackets is also still inside these curly brackets, so that variable is in scope. So it can print, grab fruit from above it, and still put it on the screen. Primitive, but I think useful little example here of how that operates. But if I did not put this in, it would not put anything on the screen. Now, do I have to call this? Do I have to put all my function calls and stuff at the top? That tends to be the programmer's standard. So like most programmers, when they write code, tend to like define their variables and objects and stuff at the top. They have their main programming code here, function calls, whatever. And then all their function definitions tend to be at the bottom. That's kind of the general pattern. Would it work, for example, if I took those functions and put them up here? Sure, why not? Let's try it. Okay, why is it not working now? Now it's saying, cannot use local variable fruit before it is declared. Okay, so there is a problem. There's a reason why we put the stuff at the bottom. You guys are catching it now? Because here it's calling on fruit, but programming code reads top to bottom. So read the function definitions, great, no problem. Read apples, oranges, and then fruit. Well, fruit is the result of a function returning a value. That hasn't happened yet. So it does, well, and John, I saw you nodding your head, right? Yeah, right. So be careful of that one. There's a reason why programmers do it in this order. We declare all our variables at the top, all our data at the top. We kind of have our main actions, and then all the stuff that, you know, the functions do is usually at the bottom of the program. That was a really good example, I thought. All right. Now, here's another scenario. We looked at how return statements work. It is also possible, right? And this is one of those weird things that you can actually have multiple return statements inside of a function. Here's the catch with that, though. Only one of them will do the returning. And a really good example or correlation here between switching case and return statements is in those case statements, only one of the cases will ultimately stick. So only one breakpoint will be reached. And a break in a case statement is your way to return to the program. And then in a function, the return is the value we're sending back to the main program. But given the fact that this is an if, else, can't hit all three scenarios, right? Only one of the scenarios is going to happen. So like, for example, if we're going to get the tax rate, so Wisconsin's got a 5% tax rate. Minnesota has almost a 7% tax rate. And what state's got a 0 tax rate for sales tax? There is one. Does anybody know what it is?
Isn't it Texas and Florida?
No, it's not. Well, you know, I can't say that with certainty. I'm pretty sure Florida has one. Alaska does not have a sales tax. The other interesting thing about Alaska, and this is true, if you establish residency there, they give you money. Hi, I've moved to Alaska. I'm a permanent resident. Here's a check. Welcome. Yeah, and what it is shared revenue from the oil pipeline, by the way. Yeah, those are really kind of interesting historical pieces of information. Strangely, they don't have Illinois on here. Does anybody know what the tax rate is in Illinois? Anybody? No. Yeah, it's much higher. I think it's like 8% in Illinois, something like that, 8.5%. And if you end up in Cook County, right where Chicago is, it hits 10%, right? And the real fascinating thing. So why is Woodman's situated like right over the border in Kenosha? You know, because yeah, the sales tax is much higher over in Illinois. Here's another little secret that a lot of people don't know. In most states, you pay sales tax on your food from the grocery store. Wisconsin does not do that. So you can save a lot of money if you live in northern Illinois, drive across the border and buy your groceries and go back. So that's not a small chunk of change. Another thing a lot of people don't know about sales tax rates is there's different sales tax rates depending on the kind of activity you're doing. So if you go to like a restaurant or a theater or a concert or a hotel, they have a different tax rate, which is usually higher than the standard tax rate. I think here in Milwaukee, it's like 8 or 10% for a restaurant. So you go split a bill with your friends at the restaurant, you have 20% for the tip and 10%. So you're adding 30% to your bill, you know. So next time you split a bill, think about that, you know. All right, so let's go back to the return statement. Okay, so the return statement doesn't have to be the last line of the local function. That's true. But once you hit that return statement, you are popped out of that function altogether. So, you know, the if else if thing is a really good example of it. There's more code that follows, but if you hit the first scenario on this slide, none of this other code is going to execute. The moment you hit a return statement, you're popped out and you're done. Okay, executing the return statement will execute the function. We just said that all possible paths through the function must result in returning the correct data type. You have to have a way out and you have to have a correct data type return. Okay, so those are important. All right, we finally made it to that last slide. And what I'm going to do is I'm going to pause the recording here because I do want to kind of make this, I guess, a little challenge thing that we're going to do. So let me hit that little pause button. Get it up on my screen, that is. There we go. All right, so here's our challenge. You've been tasked with creating a clairvoyance tester program. It should have a local function that generates and returns a number between 1 and 10 using this code. So in other words, kind of giving you a little bit of an example of how we might call it, right? So first of all, we're going to have an integer of a random number, and we're going to say new random dot next 1 comma 11. After that function is called, ask the user for a number between 1 and 10. So this is a number guessing game is what this is, right? Create another local function that takes the random number and the user guess number as input. If they guessed correctly, return the string, you are clairvoyant. If not, return, sorry, you do not have clairvoyance. Right? I don't know if you guys are kind of catching the nuances here, but here's the secret sauce. This statement up here, new random dot next 1 through 11, is it refers to a built-in library of functions that randomly generates numbers between 1 and 10. This kind of works. It excludes the 11, by the way, so it only will go from 1 to 10. Okay. So if you run this code in your program, that will generate the random number. So that's the little piece we haven't talked about yet. I'm going to pause the recording and then we're going to work on this. All right, welcome back to the main session, everybody. I'm going to show you what my solution is for this problem, and yours might look very similar or very different. You know, that's all in interpretation, but I was reading it, I think, pretty clearly, right? So here's the challenge. So we're going to create a clairvoyance tester program. It should have a local function that generates and returns a number between 1 and 10 using this code. And so there's this random number generator. And you know what? I kind of wrestled with that a little bit, and I think I left both versions of it in there, but I'll show you what I did. After that function is called, ask the user for a number between 1 and 10. Create another local function that takes the random number and the user guess number as input. And if they guessed correctly, return the string, you're clairvoyant. If not, return, sorry, you do not have clairvoyance, right? A lot of interpretation there, but it is really relatively pretty basic. And so the first thing that I did, right, is I went right to this random number code. So I'm just gonna, because that was given, right? And real frankly, having it set up as a function, maybe not so necessary because it's really pretty simplistic, right? But here's the kind of the fun part about this. As you set it up as a function, right? I can call that exact line. So it calls the random function, a random number generator from within the language. So it picks a number between 1 and 10, stores it in a variable, right, as an integer, and then returns that integer back to the main program. From the main program, I'm calling it like so. So here's the call to the function. It is returning a value, so I have to have somewhere to put it. So I set up an integer called randnum to hold it. Then I put a prompt on the screen. I say, hey, guess a number between 1 and 10. I capture that number. Of course, I make sure it's converted to an integer because remember the keyword, you're typing a string. So we're converting it right away and storing it in an integer. Then I'm gonna, well, okay, so it looks like I'm creating a message, but really what I'm doing here is I'm calling my next function where I'm sending the user's guess and the random number that was generated to this function. And I want to show you, I did it 2 different ways. So the first way I did it was with a regular if statement, right? So check that out. And this is going to return a string. And what is it going to return is basically those messages. But I'm sending in the user's guess as an integer and the random number that was generated. And I found it really interesting when I was writing this code in particular, and I got to this point, it suggested that I use the same variable name I had out here. And I didn't like it. So I changed it, by the way, because I'm not comfortable with that technique. So I called it user guess here, but really it's taking this and putting it here, right? Then another one for the random numbers. Notice the slightly different naming. That way I'm sure that the stuff inside the function, excuse me, does not conflict with what's outside the function. That's just my fail-safe as an old school programmer. When I get inside that function, I set up an empty string that's going to be the result of the whole thing. And then I first did it with an if statement. I said, okay, if the user guess equals the random number, the result is you're clairvoyant. Otherwise, the result is sorry, you're not. Okay. And then at the bottom, I return the result. Now, I thought to myself, hey, wait a second, we did those ternary operators before. This is a perfect use case scenario because I'm going to pose that if statement here, use the ternary operator of the question mark. And if that's true, if they're correct, I'm going to put you are clairvoyant in the result variable, or sorry, you do not have clairvoyance. It's one or the other, right? Perfect scenario for it. I thought, let's demonstrate both. Okay, and this approach occurred to me after the fact. So you may have done the same approach, maybe not. And then ultimately I'm returning the result, right? So I have the two functions that they asked for, the random number generator, which returns an integer, and the compare guess, which really, if I think about this, I could have really boiled it down to much less code. In fact, I could have even declared it as a string right here. So I could have kind of trimmed down my code to this. Right, I could have just did this. See how simple that is, right? And really, keep in mind, this is all that code's on one line. It's just wrapping because I have, word wrap turned on, but it is all on one line. It's 2 lines of code. I think it's really, really elegant and simple. And of course, maybe you guys should be screenshotting it. Remember, it's not an assignment though, so there's no points attached to this. So this is more a learning point. And then if I run it, right? And so far, every time I've tried, I have not been clairvoyant, by the way. And I've tried a bunch of times. Let's give it a few more tries to see if I get lucky. Right. What are the chances I'll succeed? 10%, right? 10% chance. Not a very good chance. Much better than winning the lottery, though. Right? At least I have a chance to get it right. So I should probably run it enough times so that I could potentially, get a win. All right. So that was my approach. Who else actually got a solution to work that wants to share? Anybody?
I did. Hang on one second.
Alex, you are muted, but feel free to go ahead and do a
Cool.
screen share.
Sure.
The recording should transfer over to the screen share.
Okay.
Alex,
Share. Okay. There we go. Can you hear me? Can you hear me? Is that? Yeah. Okay. So,
Yes.
okay. Awesome.
Now, we are not hearing you, by the way, or at least I'm not hearing
Oh.
you. So make sure, do you have like a
I-
software mute?
I
on
can
your
hear
mic?
him.
I can hear him too.
Hardware mute.
I think he can't hear us.
I think he can't hear
I can
us.
see you're
Yeah.
lit up, but I'm not hearing you.
Yeah. Well,
Volumes are
in
turned on.
just
Can you guys hear Alex? You guys can hear Alex,
Yeah, I
right?
can hear Alex.
So I'm the one epically failing here. All right, Alex, let me see if I can. Oh, here we go. Try again, Alex.
Okay. How's this? Are we good? No?
Yeah, I'm pumping it through my laptop,
Okay.
but I'm hearing you. That's what matters.
Okay. Awesome. Awesome. So in mine, I forgot to put this into a function or a method, and I just kind of left it on a line because it worked anyway, at least for this particular instance. And I wasn't going to be calling it again later for any other reason, so I just left it like that. But I prompted the user first. I recorded their choice, then I rolled the random number. It seemed to have the same effect in the end. Then I call the function, which I declared below, as with the void, because it's just going to return one string or another. I did not use the ternary operators. Didn't think to use it at the time, but I like it. I like that. It's a lot more concise. But when I run it, it at least seems to work. I just used the same number for each of my tests. I just used 7 until I got a match. It took me like 15 or 20 tries, but I did eventually get a match, and it did say you are clairvoyant. So that was good. Yeah.
Very interesting. I think, there's a little, when you look at that slide, or the description of what we were supposed to do, right? It does ask you to return a string from the function, right? So you're not technically doing that, but
Sure.
it does work, right? So the difficulty isn't getting the logic to work. It was really more about passing parameters and returning values.
Gotcha.
And that was kind of the trick there. But either way, I started out with the random thing in the same fashion. I'm like, oh yeah, they said that you should put it in a function and return it, which is okay, whatever, I'll do it, trying to follow the instructions to the letter. And you know what? You do have it working either way, right? And once again, the user doesn't care
Right.
how it works as long as it works. Does anybody else have a solution or a partial solution they want to share?
I do.
All right, Alex.
All right. Just make sure it's the correct one. All right. Do you see it?
Yes.
Yeah, so I just create the variables and the random number function. It just gives me the random number. I use the code exactly from the slide. I ask the user for a number, and then I call this, and then I compare the user number to the random number, and it returns this if true and this if false. I'm I also used number 7 to test.
Interesting, because that was the number I most often typed in too. What is with that, right?
I got on my 3rd try.
There's some
It
sort of
is the number
context.
most often rolled on a set of dice.
Well, that's because that's what's most probable to happen. Why are we all choosing the same number from the keyboard?
It's the best number. That's why.
We all feel like it's the luckiest number, apparently, right? Kind of, I think what's kind of interesting about this solution is you declared your random number variable globally, right, up at the top. And so when you ran the random number function and it was assigning the random number directly to random number, right? So you didn't use the code exactly it was provided. You kind of hotwired it a little bit. So basically on line 16 through 19, where that random number function is, we're not returning anything because it's setting a variable that's outside of the function, which is doable, right? And it can do that because they're all inside the same scope, basically. So I think this is an interesting way to do it too. Notice different solution, right? Once again.
Yep.
All right. Now we had another group working on this too, and I don't know if you guys actually finished, but I'd love to see what you were working on. If you guys are willing to share.
We were trying to get the structure right. We didn't get the structure right.
Okay.
So procedurally, we were trying to figure out what to do first, or the steps of the organizational program. We didn't get there.
Okay. So you don't want to show?
No.
Okay. Right. So that's not an obligation. You know, the flip side of that, John, is we could look at it and fix it. You know, that's the flip, right? But you know what, here my hope was to end early. Oh, well, you know, we didn't do that, but I'm hoping that you guys learned a lot during the course of the session tonight. So when we do get together on Thursday, the primary focus is to work through coding exercises. If you come in prepared, I appreciate that. If you don't, that's fine too, right? Because we'll code through everything in class as best we can. And with any luck, maybe we can even do some of the Codio stuff together, just to kind of see like where that's at and how you guys are functioning with it. But that's it for tonight, folks. We're going to call it a night. Thank you for a good session. And I will
Thanks,
see
Jeff.
you on Tuesday. No,
Thanks very much, Ty.
Thank you. Have a good night.
take care.